Alright, hi you guys and welcome. Today we'll be talking about zero and negative exponents today and some definitions we need to go over. Okay. Alright, so first off, let me get some colors. Let's go. Okay, this we'll be referring to as a base. Okay. So that one's pretty simple. So this is the base number. Okay, this number up here is the exponent. Okay. Right, and so what this basically means is b times b times b times b times itself a times. Okay, so if we're talking about, let's say, 3 squared, and this is how we'll usually write it with the caret, that just usually means this little form right here. So it'd be a 3 with a little 2 up here, okay, and that just means 3 times 3 twice. Okay, and we simplify that to 9 usually. So usually when you have numbers, you simplify. Simplify. Just makes your job a whole lot easier. Okay. Alright, so when you have numbers, simplify. However, when you have just variables, you don't need to simplify, and this just means x times x. Okay. Alright, so what we're doing is we're going to first look at zero and negative exponents. Now, here's a cool thing. Here's the simple definition. X to the 0 is 1, and x can be anything. Okay. Right, including 0. Now there are some schools of thought that think that 0 to the 0th power is equal to 1 or is undefined. It depends on which school of thought you are. So right now, for just the sake of argument, we are going to believe it's going to be this first part. It's just going to be straight up 0 to the 0 power is that, and we're not going to be worried about the undefined, okay? Alright, so that's the most amazing thing about it. Now, could you have a whole bunch of stuff in there, like 23 x to the 7th times y to the 25th, all raised to the 0 power? Because everything in here is being raised to the 0 power. This technically counts as one number in here. That's one term. It's being raised to the 0 power. This whole thing will turn into 1. And I'll show you later why it turns into 1. We'll do a proof on it. Okay? Alright. Now, negative exponents are... There's actually a really great definition on mathisfun.com. If you go look at it, negative exponents are like how many times I'm dividing. So technically, this you could say is 1 divided by 3 divided by 3. Okay, which turns into 1/9. Okay, simple as that. Which also is the same as 1 over 3 squared. So technically, what is actually happening is that if we put this as a fraction over 1, we brought this entire thing down here, leaving a 1 in its place. So we had the 3 squared down here. Okay, so that's a really neat thing that we can actually do with this stuff. Okay, now do we bring everything down that's associated with a negative exponent, or is negative? Well, negative 3 to the 5th. Okay, you also have to understand there's two different types. There's going to be parentheses negative 3 to the 5th. Okay, and then there's going to be no parentheses. Now this is just basically a negative outside of 3 times 3 times 3 times 3 times 3. Okay, so that one's just going to have that negative there. Whereas this one down here, when you have just the parentheses around the negative 3, that is going to be negative 3 times negative 3 times, oops, let's get that there, negative 3. What do I have? 4? Oof. This takes a lot longer than what I want it to. Okay, and then you would actually calculate it out. Now this number they would both be negative when you put it in the calculator, but you have to be careful how you put it in. Now if you put it into Desmos, you'll actually get pretty much the correct answer, but you want to be careful about your parentheses when you're putting it in. Okay, so now if you notice, the exponent wasn't negative, so I didn't put this as kind of like, it's almost like when you do negative exponents, you're dealing with reciprocals. Okay, but if I have a negative base, now remember there's two different numbers here. We got the base and the exponent. So the exponent, this is the reciprocal part. The base, you just treat it as a regular number that you're multiplying out a certain amount of times. And remember, exponents are just shortcuts for multiplying many times. Okay, right? So when you're multiplying this stuff out, you get there. Now if we did want to mix this up and we did have, like, let's say negative 3 raised to the negative 5th power, okay, once again we would have the negative in front, and then it would be 1 divided by 3 divided by 3 divided by 3 divided by 3, and one more divided by 3, which is the same as negative parentheses 1 divided by 3 to the 5th. Okay, and if you try that out in Desmos, you should be able to see it pretty easily. Okay, all right, now if we did the parentheses around it, I'm going to cut it out because it takes so long to type. Oh, okay, and usually you put the negative 5 in parentheses, and if you put it in Desmos, it really does a well job. Okay, this just becomes 1 over negative 3 to the 5th. Okay. Now granted, once again, they're both going to be negative, but with this part right here, when you're dealing with the negatives, it's going to be a negative on top of all of this. So whatever answer we get, you're going to add a negative to it. Whereas this one, you are actually multiplying negative 3 5 times in the denominator of a fraction. Okay. All right, now some of these questions that are going to pop up for you are going to appear like this, and you just have to rearrange it so that there is no positive exponents. Okay, so if they just basically present you with a question like this, you're going to have to actually put it into that form. Whereas if you're down here and you have to transform it into one where t to the a times r to the b, oops, well, if that's like that, I should probably change that to an r. There we go. That's much better. Okay, and where a and b are just integers. Now if you notice, we're going to talk about that one in a sec. Okay, so taking a look at this first one. Okay, so in the reciprocal already there's a negative exponent, so when we flip it, it's going to be x to the 7th over 1, which just becomes x to the 7th. Pretty simple. Okay, now if I do this for each one of these terms, okay, and let's pretend it's over 1, okay, I'm going to find that this is the only one I'm going to be flipping. Okay, so when I flip it, it's going to become 1 over c to the 5th, and this one's going to be d to the 7th over 1, which will just transform to d to the 7th divided by c to the 5th. You can write it either way you want. Okay, and if I apply that same logic to this, there's 3 separate things going on here inside this one term. Okay, these two would be the only two that I flip. Okay, so this whole thing turns into x to the 3rd divided by parentheses 5 squared, which I'm going to turn into 25 because that's pretty simple enough. 25 y to the 1st, so I'll just leave it as 25y. Okay. All right, remember when we flip them, they actually become positive exponents. Okay. Now there's a lot going on this next one. Okay. So if you separate it into all of its terms, we just have 7. You could almost say it's 7 to the 1st. Okay. Then we have s to the 0, and then we have t to the negative 5th. Okay, and then over here we have 1 over 2 to the negative 1. And then we also have 1 over m squared. Okay, and then what we do is we just put these over 1. So these ones over 1. And this is just basically simplifying everything down to the point of where you don't have 0 or negative exponents is what they'll ask. Okay? Alright, so this one I leave alone. This one I will change, but this one actually just turns into a 1. So that's pretty easy. This one I will flip, and this one I will flip. Okay? Alright, so when I rearrange it, I'm going to have 7 times 1 from the s to the 0 times 2 to the first, which is just that. So that's the top portion. That's the numerator of my fraction. On the bottom, I'm going to have t to the 5th, okay, and then I'm going to have m squared because m doesn't get flipped. Okay, and then I just rearrange everything, and I should get 14 over t to the 5th m squared. Okay, so that one's pretty simple. Now, if you have to evaluate, what I strongly recommend is pick one method, either plug in and then evaluate, or kind of get rid of the negative exponents first and then plug in. So I'm going to strongly recommend rearrange without negative exponents and then plug in your actual numbers and then find it out. So this one's going to stay, the r cubed is just going to stay up top, but I'm going to divide by s squared. Okay, and then that just turns into 2 to the 3rd on top. Yep. And then parentheses, negative 4. Remember, parentheses are important with this. To the 2nd. Okay, now on top that turns into an 8. On the bottom that turns into 16, and this whole thing turns into 1/2. Okay? Alright. Now remember, the reason why this negative turned into a positive is that it's negative 4 times itself twice. So in other words, I'm timesing by another negative 4, and negative 4 times negative 4 is definitely going to be 16. Okay, now this one, once again, I rearrange it. Now I don't do anything with the 4, but I do stuff with the s to the 3rd. So this is going to become 4 over s to the 3rd, which becomes 4 divided by parentheses, negative 4 to the 3rd. Okay, now this one's going to have 3 negative 4's, and if you check out on your calculator, that's going to turn into negative 64. Alright, and 4 divided by negative 64 is going to become negative 1 over 16. Okay, now if you have to transform into something where all of the letters are in the numerator no matter what, this is almost like the reverse of what we've done. Up here we had everything just kind of laid out, and then we just kind of rearrange it into its proper spots. Up here we're going to actually rearrange it. So if you notice, both my terms are in the denominator, so I'm going to move them both up. Now when I move them, they're going to become opposites of each other. So this only goes when you have to follow these directions. You're not going to do this every time. So this is going to become t squared. That's pretty simple. And then this one's going to become r to the negative 3rd. Okay, and that's okay because you're doing exactly what the directions ask. Alright, now that's it for 0 and negative exponents. I believe I talked the heck out of it, and I will talk to you guys later. Bye.